Hello students, welcome to the session. In the last class we have learned about the conversion, that is converting from decimal system to binary, decimal to octal and decimal to hexadecimal. So in this session let us talk about the conversion from binary to decimal, octal to decimal and hexadecimal to decimal. So as we had already said earlier, the process that you are supposed to follow here is multiplication. Okay, so first step, let us learn about the conversion from binary number system to decimal number system. Example, let us take a number 11011.101 which is in the base 2 to be converted into base 10. As we had said earlier, 11011.101. This is your decimal point. To the left side of this decimal point, start giving the powers starting from 0. 1, 2, 3 and 4. To the right side, we give minus 1, minus 2 and minus 3. So now, what are you going to do? Take this number. This is to the base of 2. So take the first number, that is 1 into, this is the base 2. So 2 to the power of 4. This is your power. So 4 plus, continue this process. 1 into to the base 2, right? 2 to the power of 3 plus, this is your 0 next number. So 0 into the base is 2 to the power of 2 plus 1 into 2 to the power of 1 and then plus 1 into 2 to the power of 0 plus, this is your 1 into 2 to the power of minus 1 plus 0 into 2 to the power of minus 2 plus 1 into 2 to the power of minus 3. This is your one step. The next step, what happens in the next step? So what is this? 2 to the power of 4? 1 into 2 to the power of 4 is 2 to the 4, 4 to the 8, 8 to the 16 plus 1 into 8 plus any number multiplied by 0 is 0 plus 1 into 2. 2 to the power of 1 is 2. Then again 1 into 2 to the power of 0. Any number raised to the power of 0 is 1. So 1 plus 1 into 1 divided by 2 to the power of 1 plus any number multiplied by 0 is 0. So we are taking it as 0 plus 1 into 1 divided by 2 to the power of 3. Minus 3 becomes plus 3 because you have written it in a fractional format. So 1 16 is a 16 plus 8 plus 2 plus 1 plus 1 by 2 is, when you divide 1 by 2 you get the answer as 0.5, right? So again this plus 0 you are leaving and then 1 into 2 to the power of 3. That means 1 divided by 2 to the power of 3 is nothing but, this is nothing but 1 by 8. So 1 divided by 8 is 0.125. So what is the final answer now here? 16 plus 8, 24, 25, 26 and 27. 27 0.5 plus 0.125 becomes 0.625. This is your conversion from binary to decimal, 27.625. Okay, in the same way we will go for the octal also, but the only difference is that instead of taking the base as 2 over here, multiplying it by 2, we are going to multiply by 8. So octal to decimal conversion. Take the number, for example 234.56 which is in the base 8 to be converted into base 10. So this is your to the left side of the decimal point, 0, 1, 2. and then -1 and -2 to the right side. This becomes your, this 2 into the base is 8, so 8 to the power of 2 plus 3 into 8 to the power of 1 plus 4 into 8 to the power of 0 plus, now you are going to take the digits to the right side of the decimal point. So that becomes your 5 into 8 to the power of -1 plus 6 into 8 to the power of -2. Right? So this is your 2 into 8 to the power of 2 is 64 plus 3, 8 to the power of 1 is 8 plus 4 into any number raised to the power of 0 is 1 plus 5 into 1 divided by 8 plus 6 into 1 divided by 8 to the power of 2. The same thing you are going to write, but the only difference is you are not going to mention the negative sign over here. Okay, so the next step, what is 2 into 64? 128 plus 3 8 is 24 plus 4 plus 5 into 1 divided by 8 is 0.125 plus 6 into 1 divided by 8 to the power of 2 means 1 divided by 64. That becomes 0.03125. So add all the integer parts, that is 128, 24 and 4. So what is the answer? 8, 16, 5 and 1. 156 you got. That is the sum of 128 plus 24 plus 4. Plus, now add, multiply this two. What is 5 into 0.0125? 25, 12, 6. Right? 0.625 plus 6 into 0.03125 becomes 30, 15, 7, 0.1875. So if you add this to your 0.625, what do you get? 12, 11, 8. Right? So what's the answer now? 1 by 8. 1. What's the answer you get for 1 divided by 8? 0.125. 5 is a 25. Okay, 0.625. This becomes 0, 5, 12, 10, 11, 6, 7, 8. So 156.81250. So this will be your answer. That is conversion of octal to decimal. Now let us, in the same way, let us go for the hexadecimal. That is hexadecimal to decimal. So that is, consider a number 5AF point D to the base of 16 to be converted into base 10. So as we said in the last session, hexadecimal means you have numbers from 0 to 9 and numbers from 10 to 15. So 10 is represented as A, B is represented as 12, 11, and so on till your 15. That is, F represents 15 in hexadecimal. So when you are going to take these numbers, you have again 5AF point D. So to the left side of the decimal point, so this is your 0, 1, 2, and to the right side you have -1. So what is this 5 again? This is to the base of 16. So the first number 5 into the base is 16 to the power of 2 plus A into 16 to the power of 1 plus F into 16 to the power of 0 plus D into 16 to the power of minus 1. But as we had said, 15 into 16 to the power of 2 is okay. What is 16 into 16? What is 16 into 16? 16 into 16 gives you 256. A is represented as 10. So you take that digit 10 into 16 to the power of 1 is 16. F is represented by 15 into any number raised to the power of 0 is 1. So 16 to the power of 0 is 1. Plus, what is your D? You have A, B, C, D, E and F. A is represented as 10, B 11, C is 12, D is 13. So 13 into 1 by 16 to the power of 1. So what is your 256 into 5? 1280 plus 160 plus 15 ones are 15 plus 13 into what is your 1 divided by 16? 1 divided by 16 gives you 0.0625. Right? So add this integer part, that is 1280, 160 and 15. 1280, 160 and 15. This gives you 1455, right? Plus 13 into 0.6025. What is the answer? That gives you 0.8125. So this is 0.18125. Add these two now. The final answer will be 1455.8125 to the base of 10. This is your conversion from hexadecimal to decimal. This is the method you are going to follow to convert the number system from binary, octal or hexadecimal to decimal. That is, logic is multiplication. Remember that, multiplication. If it is binary, multiply the numbers by 2. If it is octal, multiply the numbers by 8. And if it is hexadecimal, multiply the numbers by 16. And there is one another method. We have done the conversion from decimal to binary, octal or hexadecimal, and we have also done the conversion from hexadecimal, binary or octal to decimal. Other than these two, there are other methods also. There are other types of conversions also. That is your octal to binary, or it can be from binary to octal, or it can be from binary to hexadecimal, or it can be from hexadecimal to binary, or it can be from octal to hexadecimal. Any this conversion, interconversions can be there. So how are you going to do this conversion? Let us see this part now. Okay, so let us first go for the binary to octal conversion. So what you are supposed to remember is there are two methods of conversion here. One is the longer method, one is the shorter version, shortcut method. If you are going for the long version, then if you have a binary number, then this binary number has to be converted into a decimal number, and then this decimal number will be converted into a octal number. This is your way of doing one method. That's a long method. Or if you have a go for a shortcut method, it is very easy. That is, you are going to group the bits. In the shortcut version, you are going to group the bits with 3 bits, because 2 to the power of 3 is 8. So octal means 8. So 3 bits, you are going to group together 3 bits and then convert this each group into its equivalent octal number. Okay, so let us just say for an example, you have a number 1010111. Okay, this is in base 2. You have to convert it into base 8. So take this number and starting from the first, that is LSB. Okay, start to group it together. You have 1010111. So the first three numbers, this is the one, this is one group. 3 bits, I said 3 bits. So this is 1, 2 and 3. Again 1, 2 and 3. And again you have one over, only one over here. If you have only one over here, you can add 2 zeros to the left hand side. Okay, so what is 111? For this you have to know the binary conversion. Now what? The representation of binary numbers to decimal. So just have a glimpse of that. Now for example, 3 bits. We are saying 3 bits. This is your 3-bit number. Okay, 0, 0, 0. That is 2 to the power of 3, right? We had said 2 to the power of 3 means 8. So you are representing it as 3 bits. So this is represented as 0. And the decimal system, what do you do? If you have 0, add 1 to that, it becomes 1. Add 1 to that, it becomes 2. Add 1 to that, it becomes 3. Again 1 to that, 4. 1 to that, 5. Right? This method is followed. In the same way, you are going to keep on adding 1 to each and every number. This actually comes in the later part, but as you require this over here, I am going to tell you this here. So 0, 0, 0, add 1. If you are going to add 1 over here, what happens? 0 plus 1. You have to follow the method of binary addition for this part. So binary addition. What do you mean by this binary addition? Before going for this representation, let us know about the binary addition. 0, 2 numbers, usually binary by. So we are going to add using 2 numbers. So 0 plus 0 is 0. 0 plus 1 is always 1. 1 plus 0 is always 1. And 1 plus 1 is a 0 plus carry of 1. You are going to carry 1. So this is the method, rule for your binary addition that you have to know. Now I'll just tell you. Now you have 3 bits as we said. 0, 0, 0. You add 1 to this. So this is your 0, the first number. Because binary you have from 0, 1, 2, 3, 4, 5, 6 and 7. So 0, 0, 0 is 0. So you add 1 to this LSB. LSB means least significant bit. 0 plus 1 is, according to the rule, 1. So this is 0, this is 0. So this is your 1. Okay, and again add 1 to this number. So what happens now? 1 plus 1, what did we say? Here 1 plus 1 is 0 plus carry of 1. So 1 plus 1 is 0 with a carry of 1 here. So again 1 plus 0 is 1 and again 0. This is your 2. Again add a 1 number. 0 plus 1 is 1 and this 1 remains as it is and 0. This is your 3. Okay, and again add 1 to this LSB. What happens? 1 plus 1 is 1 plus 1 is 0 with a carry of 1. Again 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1. This is your 4. Again add 1. Till where are you going to continue? Till you reach your 7, because that is the last number. And also you are going to reach all the ones over there. 0 plus 1 is 1, 0 and 1. So this is your 5. And again add 1 to this. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1, 1. This is your 6. And again add 1. 1, 0 plus 1 is 1, 1, 1. So this is your 7. Okay, this is how you are going to represent your 3-bit number. So remember this now. We had said we have taken the number as, what was the example? 1010111. So 1010111. So you are going to divide it into 3 bits. So if you do not have anything, then we are saying to the left side you add 2 zeros. What is this 111 is a group now? Right? So 111 is a group. What is this? 111 means 7. So write 7 here. 0, 1, 0. See now in your table, what is 0, 1, 0? 2. Right? So 2. 0, 0, 1. What is your 0, 0, 1? 1. So write here 1. So this is the easiest way, that is 1010111, which was in binary, is represented as 127 in octal. Okay, this is the way you are going to do it. And if you have a fractional part means, for example, you have 0.110111 to the base 2, that is to be converted into base 8. What are you going to do now? In the fractional whole number part, we took from the left side. But now we have to take it from the right side. That is 1, 1, 0 is 1. 1, 1, 1 is the one group. If you have again a shortage, that is if you have only, for example, if you had only 2 digits over here, 1, 1, then you can add 0 here in this part. But now they have given it as a 3-bit only. So we are doing it as it is. So what is your 110? What was 110? 6. And what is your 111? 7. So this is your 6 and this is your 7. So 0.110111 is nothing but 0.67 to the base of 8. Okay, this is how you are going to convert a binary number to your octal number. It's a shortcut method. Okay, hope you have understood. Now, let us go for the next part, that is your octal to binary, the vice versa. Okay, again this is also very simple. Now for example, you have a number 456 which is in the base 8. You have to convert it into base 2. How are you going to do this? So as we said, you have a table, you write this table 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay. Right? This is the numbers you had. Now, what is your 4 is represented as 1, 0, 0. What is your 5? 1, 0, 1. What is your 6? 1, 1, 0. Finished. You are represented it in binary. Is it not easy? That is why we call this as a shortcut method. Now I am going to give you one more example, that is 73.16, which is in base 8. You have to convert it into base 2. I am just going to give you 2 minutes of time. Try to answer this. Okay, finished? Did you get the answer? What is 7? 7 means 111. 3 means 0, 1, 1. Point. Keep that point. Do not forget to keep that point. 1 means 0, 1. Sorry, 0, 0, 1. 6 means 1, 1, 0. This is what you are going to do. This is how you are going to do this conversion. Okay. Hope you have understood this. Now let us go for the next, that is your binary to hexadecimal conversion. Binary to hexadecimal conversion. Now again, instead of hexadecimal means 2 to the power of 4, that is 2 into 2 into 2 into 2, that is nothing but 16, right? So how are you going to represent it? We are going to represent it in the terms of 4 bits, that is your 0, 0, 0, 0. The method will be the same, that is add 1, so this is represented as 0, and then 0 plus 1, 1, 0, 0, 0. This becomes your 1, and then add 1 to this. Again, this 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1, 0 and 0. So this is your 2. And then add 1. 0 plus 1 is 1, 1, 0, 0. This is your 3. Again add 1. So this 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1, 0. This is your 4. Again 1, 1, 0, 1, 0. This is your 5. Right? So 0, 1, 0, 1. This was your 5. Add 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1, 1, 0. This is your 6. Then add 1 to this. That becomes your what? 0 plus 1 is 1, and then 1, 1, 0. This was your 7. Right? Till now you know this. Next again add 1. So 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1. This is your 8. And again add 1. 0 plus 1 is 1. 0, 0, 1. This is your 9. And again add 1. 1 plus 1 is 0 with a carry of 1. 1, 0, 1. This is your 10. And again add 1. 0 plus 1 is, yes, 0 plus 1 is 1, 1, 0, 1. This is your 11. 10 is represented as A, 11 is represented as B. And again add 1. So 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1, 1. This is your 12. That's nothing but your C. And again 1. 0 plus 1 is 1, 0, 1, 1. This is your 13. That is your D. And again 1. 1 plus 1 is 0 with a carry of 1. 1 plus 1, 0 is 1, 1, 1. This is your 14. That is your E. And again 1. 0 plus 1 is 1, 1, 1, 1. This becomes your 15. That is your F. Okay. So this is how you are going to represent it in binary. Sorry, the zeros and 5 1 format. For the shortcut method. This you should know. Hope you have understood that. And in the next session, you please do practice this format, that is your conversions of binary to octal, 3-bit and 4-bit. Practice it so that you become perfect, and in the next session you can easily answer and by heart this also if you can. It is 0, 0, 1, 0, 0, 0, 1 means 1, 0, 1, 0 means 1. 0, 0, 0 is 0, 0, 0, 1 is 1, 0, 1, 0 is 2, 0, 1, 1 is 3, 1, 0, 0 is 4. In this way, just by heart and go on. And we'll continue this in the next format so that it is easier for you to understand. The sums we can solve it later. We'll continue in the next session. Thank you.